I'm sorry I can't be with you in person today. I have to be off at a training, but I'm hoping this brief recorded set of notes is going to help you understand your very first learning objective of this next unit. We're about to embark on our unit entitled Biological Basis of Behavior. So this unit is all about biological psychology, and as the picture that you see on the screen before you indicates, this heavily is going to involve us understanding how the physical structures of the body, including the brain, give rise to certain human behaviors and abilities. And a lot of my students kind of readily accept that if you're going to understand stuff about human thought, you might have to understand some things about the brain. But sometimes people actually take issue with this. They wonder, okay, well, I signed up for a psychology class. Why are we filling out anatomical diagrams with brain parts on them, Mrs. Welly? Well, there's a reason for that, which I hope I'll be able to explain here. And in fact, it connects to our very first learning objective of the unit, which is, okay, why is it that psychologists are concerned about biology? Why would you need to know something about brain parts and structures in order to understand human thinking and abilities and trends in behavior? Well, it turns out everything psychological is simultaneously biological. Every mental act that you engage in, whether it's memories of childhood, anticipating the future, making a decision, tasting soda that you're sipping on, all of that stuff requires activity of the nervous system. And what we're looking at here is actually a disembodied nervous system. So we've got all the nerves that innervate the various bodies, muscles, and tissues, and that connect up through the spinal cord and then reach their peak, of course, at the brain. The center of the human nervous system. And this may be a little grotesque to look at. Some people feel more comfortable viewing this thing than others, but really, this is the thing that animates your body and allows you to make decisions and experience the world. In the grand sense, the rest of your body, all the muscles and tissue, is just a meat suit that allows this thing to walk around and experience the world, which is a pretty mind-blowing thought. And given the fact that this nervous system in general, and the brain specifically, plays such a central role in who we are, our personality structures, our capacity for thought and decision making, it does make sense to pay attention to how it works. Certainly, we've got lots of examples of research that will address this unit where we look at how damage to these systems affects human behavior and abilities. And in addition to the fact that, okay, it helps us understand other stuff that we might be interested in, like knowing about humanity, there's something that's still just cool about the brain. Like, it's just interesting. The brain is so complex. Some people have pointed out that, okay, the brain is complex for a reason, that if it was so simple that we could easily understand it, that we would be so simple that we couldn't, if that makes sense. And then given its complexity, there's so many research questions that yet have to be asked and answered about our nervous system. It's an oft-repeated statement about the complexity of the nervous system that, like, we know more about the vastness of interstellar space than we do about the tissue that sits between your ears. A single cubic millimeter of brain tissue contains more synapses or neural connections between the cells within it than there are stars in the Milky Way galaxy. There are just so many unanswered questions about the brain. So even if it didn't help us explain a bunch of psychological phenomena, which it does, I think it's worth studying the brain just because it's fascinating. Now, of course, we're going to be learning a lot about modern neuroscience over the course of this unit, but people didn't just become interested in studying the brain in the 1990s when we started getting access to cool gadgets like MRIs and PET scans and things like that. There were people who had noticed for a long time that, okay, head injuries do affect human behavior. So we would assume then that maybe damaging the brain might have something to do with human behavior. And one individual that your textbook draws your attention to in Module 9 is the work of Franz Gall, who came up with a very interesting but ultimately wrong idea about how it is you could go about studying the human brain. So we had some missteps early in the history of this topic. Phrenology is this idea that if you actually feel the bumps on the human skull. So if you actually took your hands and placed them on a skull to like search for and maybe even measure the protrusions or indentations that appear on it, that you could tell some things about human personality. So it's the idea that maybe the shape of the skull, like the bumps and indentations within it, tell you something about people's ability and character. So like maybe if this area was slightly elevated or raised, that would indicate that someone had an excessive amount of cautiousness. So they may be risk averse and a very cautious individual. Um, of course, you might recognize there's some flaws with this idea, and we'll come back to that in a second. But Franz Gall actually came up with this idea by taking lots of measurements of human skulls and comparing them. So, although the theory he came up with is ultimately very wrong, we do kind of have to give him a little bit of credit for being our first comparative brain anatomist. He kind of systematically tried to study the shape of the skull, even skull volume, to understand differences between people's brains. And even though most of this is wrong, like if you look at the phrenology map now, like no person would tell you that you can feel bumps on someone's skull and figure out if they're a cautious individual or not. But he did establish this basic idea that, hey, different parts of the brain may have different functions. And that does actually turn out to be true, just not the functions he identified at all. So the idea that the brain, unlike other organs of the body, this is pretty unique to the brain, like you have two kidneys and they both do the same thing no matter what part of the kidney it is. Your lungs kind of all do the same thing no matter what part of the lung you're looking at. But the brain actually subdivides different tasks. And Gall's work drew our attention to that, even if in an inaccurate way. But you might recognize there's really some shortcomings to this idea. For one, if you looked at how Gall arrived at this conclusion, by modern standards, this is way unscientific. He actually gathered his data in a way that would probably induce a lot of confirmation bias, because he would take people that he believed shared a specific quality. So one example was he gathered data, took measurements of the skulls of a bunch of street urchins, which is a really not nice kind of pejorative term that was used to describe street kids, like during his time, which is, also just a sad phenomenon. There were kids who were basically living on the streets because there was kind of no social support safety net for orphaned children or children whose families couldn't provide for them. But these street urchins, as he called them in his notes, were they were believed to be dishonest because they often stole for a living, probably not necessarily because of core dishonesty, but because, they're trying to stay alive. But because he believed that they were dishonest, he took measurements of their skulls, looking for similarities, and identified a location that he thought had to do with honesty because it was an area that maybe there were some more indentations there. It wasn't as prominently developed in the sample that he was taking. But the problem here, as we know, based on our study of confirmation bias last unit, is that if you're looking for something, if you already believe something is true, like that you're going to find some sort of honesty area in the human skull, and you go about looking for it, you're probably going to find it, even if it's not there. Like, you're going to be able to come up with evidence. If you blinded your researchers and they didn't know if they were looking at a dishonest or an honest person, then you might be a little more objective about this, but he was way not doing that. Another problem with phrenology, and why you no longer find phrenologists around, is that, okay, if you look at these phrenology skulls, like, holy cow, there's so many things on there. And we'll learn about this in our personality unit later this year, but the best theories of personality are actually concise. They might distill down the number of basic personality traits into smaller numbers, because the more traits you add, the less measurement power each one has. And, if you get like 300 traits or something, like, then you get a theory that kind of loses its meaning and doesn't help you predict any human behavior. And of course, I hope you also recognize this. Gall was kind of assuming that the surface of the skull reflected the size and structure of underlying brain tissue, when that's just not true. Like, there's other tissue in between the surface of your skull that you would touch on the outside of your head and the surface of the brain. So they don't match up completely. Now, that didn't stop the phrenologists from coming up with like cool like gadgets that you could take as like to parties and stuff, and that was actually a fun thing to do if you're an upper middle class person in Gall's day, was invite a phrenologist to your party, and they would take readings and like tell you stuff about your personality, which is basically just a fancier, seemingly scientific way of inviting a fortune teller over. But I'm sure they had fun with it. Now we don't, there aren't any phrenologists anymore. But phrenology, of course, wasn't the only episode during which people had really weird ideas about the brain. Myths and lore about the brain continued for some time, and including in the 1950s, where they made like tons of like really crappy movies about the brain and brains that go bad or exist in and of themselves. This is a interesting time for cinematic neuroscience. So this video is definitely worth watching. This is a video clip from the brain from planet Aros, which really apparently is just like a disembodied brain going around, trashing, scaring people. Like also some cool traditional gender. Oh, let's go back to that. Some cool like traditional gender roles showing up in this video clip. It's much craziness. Yeah, oh no, what happened to that guy? Oh dear. But, yep, screaming about it's definitely gonna help. Uh-oh. Yep. Ah! Oh, shoot. You can actually even, like, see the string that's holding the... Oh, and he's got an axe, so that's helpful. Oh, yep. Oh, and the dog is watching. Like, why does the dog have to see this? Oh, no. Yep. That... Wow. Okay, and the dog's like, that was fine. Gonna take a knee. Okay. Yeah, cool. So the brain, super fascinating for a long time, and we definitely have gone astray, and maybe sometimes failed to capture its complexity. But I think, and I hope you'll enjoy this unit as we continue to explore maybe some more accurate ideas about the brain. And as we do, I hope you keep this idea in mind, that the reason that we're spending so much time filling out the anatomical diagrams is that every psychological experience you have, every feeling and every thought is tied down to electrical and chemical activity within the brain. So it's inherently biological, and we want to keep our eye on that. It's an important part of the picture. Not the only part of the picture, but an important part. So at this point, how about you head over to Socrative and try out some questions to test your own background knowledge of the brain?